Hi everyone and welcome to Algebra 2, Lesson 2.7. Now this lesson will mainly serve as a review for everything else that we know in preparation to take our test. So let's start by quadratic functions, right? This is the last thing that we kind of covered. So quadratic function, that parent function is f of x equals x squared, right? It creates a U-shaped curve called a parabola. All right, and the axis of symmetry is a vertical line that divides the parabola into two equal parts, and the turning point is called the vertex. All right, so now the standard form of a parabola kind of looks like this. Actually, let's graph it and be accurate. Our axis, or our vertex, is 0, 0. So basically, we're just going to do 1 squared is 1 and 2 squared is 4. Negative 1 squared is 1 and negative 2 squared is 4. So now when we graph it, we have 0, 0, we have 1, 1, and 2, 4. 1, 1, 2, 4. Kind of like this. All right. So now in standard form, our parabola is ax squared plus bx plus c. And the axis of symmetry we find out by doing the negative b over 2a to find the x, and then we substitute it in to find our y. So in this one, our a equals 1, our b is negative 4, and our c is positive 1. So when I use this negative b over 2a, it would be negative negative 4 over 2 times 1. So that gives me 4 divided by 2 is 2. So I know my axis of symmetry is located at x equals 2. Now, to find our y of our vertex, I substitute 2 in. 2 squared minus 4 times 2 plus 1. 2 squared is 4 minus 8 plus 1. 4 minus 8 is negative 4. Plus 1 gives me a negative 3. So now we're going to go ahead and graph this by going down 2, and then we'll go up 2, and we'll pop this in. When I use 0, 0 makes this go away and this go away, just leaving a 1. So that means 4 will also be a 1. When I put a 1 in, 1 squared is 1 minus 4 times 1 plus 1. So this gives us 1 minus 4 plus 1. 1 minus 4 is negative 3, plus 1 is negative 2. Right, and that's where we wind up. So if we graph this, we have a 0, 1, a 1, negative 2. Oops, excuse me, 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and like that. So our parabola is just going to kind of do one of these, where this is rounded. Okay, vertex form, that's our a times x minus h squared plus k. Right, and f of x, of course. Now, our axis of symmetry is where x equals h. All right, so basically, whatever the opposite of our negative h is, that's our axis of symmetry, and our vertex is h comma k. So if we want to use this one, we could see that our axis of symmetry is negative 1 because it's the opposite, and then 6. So we're going to have a parabola that's shifted 1 to the left and 6 up. So we have a negative 1, 6 as our vertex. And now we can go ahead and just go down. Oh, keep doing that. We have a negative 2, negative 3, 0, and 1. So when I go ahead and I put this in my formula here, I have a negative 2 plus 1, all squared, times 2 plus 6. Negative 2 plus 1 is negative 1. So a negative 1 squared is 2 times 1 plus 6 is 8. Oh, I see what I did there. That is a negative 2, which is my fault. Lost my negative sign. Negative 2 times 1 . Let me start that over because I'm just writing over myself. Negative 2 times negative 2 plus 1 squared plus 6. That is negative 2 times a negative 1 squared plus 6. So negative 2 times 1 plus 6 gets me a negative 2 plus 6, which is 4, and that is the correct answer. So these are going to be 4. Now when I go ahead and I'll use 1 because 1 is way easier to use in this. Negative 2 times 1 plus 1 squared plus 6. Well, negative 2 times, well, this is 2 squared, which is 4, plus 6. So negative 8 plus 6 is a negative 2. So this will be negative 2, and that'll be negative 2. So now when I graph it, I have a negative 3, negative 2, a negative 2, negative 4, a negative 1, negative 6. And we kind of come back this way. So our parabola is going to look like that. All right. So now, getting into our next page of our notes, we're just going to do a little more reviewing. So the parent function for this is what's called a linear function. I'm going to write that better. Linear. There we go. Because you see that this is in the form of y equals mx plus b, so it's a straight line. And remember, the way we graph this is that this is our y-intercept, so we go up to 5, and our slope is negative 3 over 1. So it means we're going to go down 3 and over 1, down 3 over 1, down 3 over 1, down 3 over 1. And then we can graph it with a straight line that would generally go through it. Our domain is all real numbers, and our range is all real numbers. We have one root because we only go through once. And our end behavior, well, as x goes to infinity, meaning as we go this way on the x, the y, you can see, in this case, is going to negative infinity because we're going down. And then as we go to negative infinity in the x this way, we can see we're going up. So we're going to positive infinity. The interval increasing, well, we don't have an increasing interval. But our decreasing interval is we're going from negative infinity to infinity. Because we're going down. Right? If it was this way, it'd be increasing. All right, number 2, we have the absolute value. You see that by the 2 absolute value bars. All right. Now, to graph this, we see that our vertex is going to be 1, negative 4. So I can go to 1, negative 4. And I'm right down there. Now notice there's a 1 here, so our slope on the right side is 1. So 1 up, 1 over, 1 up, 1 over, and we repeat it on the other side as well. Right? Our domain, all real numbers. Now our range is only from this point up. So we're at negative 4, so y is greater than or equal to negative 4. Number of roots. Roots are where it crosses the x-axis, which is 2 spots. It's end behavior, so as we go this way, it's going up towards infinity. And as we go this way, it's also going up towards infinity. Now, increasing interval. Right? It's technically going this way, so it's starting from 1, and it's going to infinity on the right side. So that is 1 to infinity. Our interval on the left side, it's starting at 1 and going to negative infinity. or it starts at negative infinity and 1. Because technically we're working from left to right. So negative infinity is all the way over here and we're working towards 1 before it starts going up. All right, so this is a quadratic because it's squared. Right? So what we need to do is we should go ahead and put this into, we can either put it in vertex form, or we can go ahead and just make a table of values. Right? But the domain is always going to be all real numbers. If we put it in vertex form, I can factor out my negative sign here, making this x squared minus 8x, and the negative 11's over here. I can take my middle term of negative 8 and divide it by 2 because we're completing the square. And when I square that, I get positive 16. So negative x squared minus 8x plus 16 minus 11. And then on this side, since it's positive 16, this negative sign would be affecting it if it was outside the parentheses. So I'm going to have a negative 16 over here. When I factor this, right, I'm taking whatever my b term is, this negative 4. So that's what I get. X minus 4 squared minus 11 equals negative 16. When I add 16 to both sides, I get 5. Negative x minus 4 x squared plus 5 equals 0. So that means my vertex is going to be at 4, 5. So I can go all the way to 4 and 5 right there. Okay, now how can I graph this? Well, to graph it, I'm just going to have to still make a table of values, but I figure we would work on completing the square a little bit. So my table of values, I'm not going to go nuts here. I know that my vertex is 4, 5, right? So I kind of want to work at 3 and 2 and maybe a 5 and a 6. So now I have an x squared plus 8x minus 11. So 2 squared, you can pop this in a calculator. 2 squared is 4 plus 16, 8 times 2, minus 11. All right, so 4 plus 16 is 20, and 20 minus 11 is 9. Oh, but we're negative x. Excuse me, negative x squared. So it's negative 4 plus 16. It's positive 12 minus 11 is just going to be 1. 3, negative 3 squared is negative 9, plus 8 times 9. 8 times 3 is 24 minus 11. So negative 9 plus 24, that gives me a positive 15 minus 11 is 4. This one is our vertex that we know. And we're going to get the same answers on this side because we just went up by 1 and down 1. So now we can graph this. We have 2, 1. We have 3, 4. Oops, wrong side. 2, 1. 3, 4 right there. Then we have 5, 4. And we have 6, 1. And it'll look like this. So we have 2 roots, because this is where it meets, right there and right there. Our range, well, our range is from this point down. And remember, we're using this number here. So y is less than or equal to 5, because we're going down. And behavior, well, as x gets bigger, this is going to keep creeping this way. So it goes to infinity, and this one goes to negative infinity as x goes that way. Our increasing interval, well, we're at 4, so on this way we're getting bigger, so we're going from 4 to infinity, and on this side we're going from infinity to negative infinity to 4. Okay, so number 4, we have absolute value function. And we see that we can tell that there is nothing here, so we have a 0 for the x and 6 for the y is our vertex, 0, 6. And our slope is negative 1, so we have a negative right there, so down 1 over 1. You can see the way that this is going to go. This is going to go this way. That's going to go that way. All right, so our domain is all real numbers because it's going forever to the right and forever to the left. Our range is this point and down. So that would be y is less than or equal to 6. It has 2 roots because we're meeting twice. Right there, it's n behavior. Well, it goes to negative infinity this way and negative infinity that way. So it's just both our negative infinity. Our increasing interval, well, we're going from negative infinity to 0, right? From here, we're increasing going this way. And we're going from 0 down this way. So 0 to positive infinity. All right, number 5, we could see that this is a quadratic. And we can see that we're at -2, -7. So -2, -7 all the way down here. And that's our vertex. So if we make a t-table for this, let's make a bigger one. Right, I'm going to use like a -3, a -4, a -1, and a 0. So the -4, 2, -4 plus 2 squared minus 7. -4 plus 2 is 2, right? -2. So -2 squared is 4. So it's 2 times 4 minus 7. So 8 minus 7 is 1. So that's going to be a 1. All right, so now we have a -3. So 2, -3 plus 2 is -1 squared minus 7. So 2 times the square root of -1 squared is just 1. So 2 minus 7 gives me a -5. All right, we have our 2, 7, so we should be the same thing over here. So let's go ahead and graph it. I have a -4, 1, a -3, -5, I have a -1, -5, and a 0, 1. So that looks about right. So it's just going to kind of look like this. Our domain is all real numbers, and our range is this point going up. So that is -6 or -7. So y is greater than or equal to -7. It has 2 roots because it goes through twice. All right. As x approaches infinity going this way, it keeps getting bigger and bigger forever. So that'll go to infinity. And as it goes to negative infinity, it also goes to infinity on the other side because it's going this way and up. All right. Our intervals. We didn't talk about that a lot, and I know it's asking for it all of a sudden, but we can talk about it anyway. Our interval is on this way, as it increases, it's going from technically infinity, it's going from -2 to infinity in the x's. And on the left side, it's going from negative infinity to -2. Number 6 is a linear function. Right, it's already in that y equals mx plus b, so our y-intercept is -1, and our slope is 5 up, 2 over. Then if I go the other way, if I go 5 down, I'll go 2 to the left. It's just going to look like this. All right, our domain, all real numbers. Our range, all real numbers. It has 1 root. As it goes to infinity this way, it keeps going up, so it's going to infinity there. And as it goes to negative infinity, it's going to negative infinity in the y's. Its increasing interval, well, it starts all the way at negative infinity and goes to positive infinity. So that would be negative infinity to positive infinity, and it's not decreasing, it's only increasing, so we don't have anything there. All right, and I'm going to let you guys work on 7 and 8 by yourselves.